Mars was once thought to be a geologically dead planet, smaller than Earth and losing internal heat at a faster rate. In the past, Mars exhibited significant volcanic activity, with its surface bearing traces of massive eruptions. However, these volcanic eruptions ceased long ago as the planet's interior cooled and solidified. This cooling process weakened Mars's magnetic field, allowing the solar wind to strip away the atmosphere and freeze any remaining water. Recent findings, however, suggest that Mars is not entirely geologically dead. Astronomers have analysed thousands of images of the Martian equatorial region taken by the NASA Mars Reconnaissance Orbiter's HiRISE camera between 2006 and 2020. These images reveal numerous landslides and debris flows on Martian volcanoes, with over 4,500 traces of rocks, leaving characteristic Christmas tree-shaped patterns that typically form after strong earthquakes. The longest trace was 2.4 kilometers long, totaling around 900 kilometers. About a third of these traces were not present in images before 2006, indicating that they were formed later. Only powerful underground tremors are capable of moving such large boulders, but these tremors were not detected on Mars until recently. A groundbreaking study published in Nature Astronomy in December 2022 revealed that a massive column of hot material, known as a mantle plume, is pushing against the Martian crust from below. This pressure is causing the surface to crack and generate tectonic activity. Mars was once a highly volcanic planet, and its surface still features ancient mountains like Olympus Mons, which is more than 600 kilometers in diameter and 21 kilometers high. It is the highest mountain and a volcano in the solar system, which can be seen even with an amateur telescope from Earth. In the Cerberus Fossae region, high-resolution images captured by spacecraft orbiting Mars show a large number of cracks and dark streaks of material rich in volcanic minerals called pyroxenes. Surprisingly, these outflows may have occurred only tens of thousands of years ago, suggesting ongoing activity beneath the surface. Moreover, NASA's InSight lander, which landed in the Elysium Planitia region in 2018, detected hundreds of small earthquakes and a few medium-sized ones. Most of these quakes seem to have originated from the direction of Cerberus Fossae, indicating that Mars's mantle may still be active. Computer models simulating Mars's geophysics suggest that a mantle plume 95 to 285 degrees Celsius hotter and slightly less dense than the surrounding mantle could explain the anomalies in Cerberus Fossae. This plume, centered almost directly under the fossae, would have started its activity around 350 million years ago, long after all other significant geological activity on Mars had ceased. While alternative explanations exist, the mantle plume hypothesis covers the most ground. If this hypothesis is correct, it may have significant implications for our understanding of the Martian interior and the possibility of life on Mars. A warm mantle plume could heat pockets of water enough to render them liquid, which is essential for life as we know it on Earth. As a result, scientists may now consider the possibility of life existing deep beneath the Martian surface. What factors assisted researchers in discovering that Mars became active? In what way did the latest samples collected from one crater nearly exhibit signs of life? And how can the discovery of geological activity on Mars affect future missions to explore and colonize the red planet? You're watching the Infinite Horizons channel. Here we delve into the wonders of space, explore cutting-edge scientific discoveries, and ponder the vast mysteries that lie ahead. Subscribe to the channel and join us on this journey as we expand our understanding of the cosmos and overcome the boundaries of our own little world. Since its launch in 2018, the InSight spacecraft has been keeping track of seismic activity on Mars during the Seismic Experiment for Interior Structure, SEIS. It has documented over 1,300 quakes, a number that pales in comparison to Earth, where seismometers detect between 500,000 and 1 million earthquakes yearly. Moreover, the majority of Mars's seismic vibrations are feeble, with magnitudes up to 3. The most powerful quake, measuring 4.2, was recorded in August 2021, followed by a 5.0 magnitude Mars quake in May 2022. Such an event on Earth would only shatter windows and cause minor infrastructure damage, but it was a significant event for Mars. Earthquakes on our planet are more intense due to tectonic plate movement and volcanic eruptions. Mars is less active in comparison, but the 5-point quakes suggest that tectonic processes are still ongoing beneath its surface. Shifts in magma eruptions persist, with rising magma leading to the bending of Mars's single lithospheric plate and triggering Mars quakes. Can geological activity on Mars help unravel the enigma of its habitability? Although Mars is a harsh and inhospitable environment characterized by extreme cold, harmful radiation, and the absence of liquid water, we still wonder about the possibility of life on the red planet. While large organisms such as giraffes, cats, or even hamsters could not survive Mars's harsh conditions. Moreover, they would be easily observable with telescopes and rovers. Microorganisms might be able to withstand these conditions and exist undetected. Microbes have been found to survive in extreme environments on Earth, suggesting that they could also exist on Mars, particularly in its warmer depths that are shielded from deadly radiation. The discovery of underground lakes on Mars is an intriguing development, and it implies the presence of liquid water, the vital ingredient for life as we know it. In 2018, radar instruments aboard the Mars Express spacecraft orbiting the planet detected a sizable subterranean lake near Mars's southern pole, along with 3 smaller bodies of water in the vicinity. These lakes cover an area of over 75,000 square kilometers within the Planum Australe, a vast ice-covered plain. In 2022, instruments on the ExoMars orbiter revealed the existence of massive reserves of frozen or liquid water in the Valles Marineris canyons, concealed within the canyon system that runs along the planet's equator. The water in these canyons occupies an area equivalent to the size of the Netherlands and is located just beneath the planet's surface, within the top 3 feet of soil. On Earth, subglacial lakes in Antarctica have been found to harbor microbes, fish, and other organisms, a possibility that may also hold true for Mars. Although some heat from Mars's interior is retained beneath its surface, it may not be sufficient to melt the ice. Consequently, these lakes may be frozen due to high salt concentrations. If the salt levels are 20 times or more than those found in Earth's oceans, even microorganisms would struggle to survive. To better understand this, scientists are working to determine the composition of water in the underground lakes, while also searching for life in dried up surface water bodies. At one point, Mars had numerous lakes and rivers, as well as a warmer climate and an atmosphere which could have supported various life forms. Until recently, however, no traces had been found. In 2022, the Perseverance rover made a remarkable discovery. It detected organic molecules near ancient water sources. While it was not the first time rovers had found organic matter on Mars, this finding was significant because it occurred in an area where an ancient river and lake system once converged, creating an environment particularly conducive to life. This area is located in the Jezero crater, which spans 45 kilometers in diameter. formed approximately 3.5 billion years ago, the delta accumulated sand, dirt, and salts over time. Perseverance managed to extract the largest quantity of Martian organic molecules from this mixture. Interestingly, fossils of ancient organisms are frequently discovered in similar sedimentary rocks on Earth. The shell-like instrument aboard the Perseverance rover, designed to identify organic and chemical substances, analyzed molecules from the Jezero crater. Among other elements, it detected hydrogen atoms bonded to carbon atoms. Carbon is essential for life and may indicate biological activity. It's worth noting that the organic molecules in the Jezero crater sediment are intermingled with sulfates. On Earth, sulfate deposits preserve organic matter and often contain traces of life. However, the molecules in the crater could have also formed through natural processes. Scientists hope to determine their origin more accurately once samples are returned to Earth, which NASA plans to do in the near future. In the meantime, researchers have uncovered other clues hinting at the potential life on Mars. Recently, the Curiosity rover detected an unusually high level of methane on the planet, 21 parts per billion units of volume. This is significant because on Earth, higher concentrations of methane are produced by living organisms. Researchers plan to investigate whether the gas on Mars is also related to the activity of potential inhabitants. If the methane had formed long ago, it would have already decomposed into constituent elements. Another possibility is that the gas resulted from interactions between rock and water. It all sounds very intriguing, but can it actually help us colonize Mars? Yes! Methane is not the only gas that scientists are curious about. Carbon dioxide, considered detrimental on Earth, may soon prove invaluable on the red planet. The experimental device MOXIE, about the size of a toaster, was transported to Mars aboard the Perseverance rover. Its components were 3D printed from a nickel-based, heat-resistant alloy. The device also includes a lightweight aerogel for heat retention and a thin gold coating that reflects infrared radiation. As a result, the innovative device can withstand temperatures of 800 degrees Celsius, the point at which gas transformation occurs. MOXIE has recently produced pure oxygen from carbon dioxide by separating oxygen atoms from carbon dioxide molecules and releasing the byproduct carbon monoxide into the atmosphere. Designed to generate up to 10 grams of oxygen per hour, the device produced approximately 5.4 grams of oxygen after an hour of operation during its first test, enough for an astronaut to breathe for about 10 minutes. MOXIE is particularly valuable because it relies on virtually unlimited raw materials, as the Martian atmosphere is composed of 96% of carbon dioxide. Additionally, MOXIE utilizes regolith, which covers the entire surface of Mars. After processing, this soil can be converted into fuel, breathable air, or, when combined with hydrogen, water. Both NASA and SpaceX CEO Elon Musk are closely monitoring scientists' discoveries on Mars. Musk is actively preparing for flights promising that astronauts will be seen on Mars in 2029. 14 Raptor engines of the Starship spacecraft have already been tested. In addition, NASA has selected Starship as the first crewed landing module for the Moon. If all goes as planned, astronauts will touch down the lunar surface between 2025 and 2027 as part of Artemis 3 mission. By 2040, NASA aims to send a manned spacecraft to Mars, with the ultimate goal of establishing a sustainable human presence on the red planet. This ambitious project will require overcoming lots of challenges, such as developing technologies that can generate and store energy, sustain life support systems, and provide necessary resources like water, air, and food. One potential solution to these challenges is the concept of in situ resource utilization, ISRU. By using local resources available on Mars, future explorers can minimize the amount of supplies they need to transport from Earth. significantly reducing mission costs and risks. The successful operation of MOXIE, which produced oxygen from Martian carbon dioxide, is an excellent example of ISRO in action. Furthermore, advances in space agriculture and closed-loop life support systems will be essential for long-duration missions and eventual colonization. Researchers are currently experimenting with various crops and growth methods to come up with the best options for growing food in Martian habitats. For instance, NASA's veggie experiment on the International Space Station has been testing the cultivation of lettuce, radish, and wheat in microgravity conditions. This knowledge will be invaluable for sustaining human life on Mars. Additionally, protection from radiation is a critical concern for astronauts embarking on long-duration space missions. Mars has a thin atmosphere, which offers limited shielding from harmful space radiation. Consequently, researchers are investigating novel materials and construction techniques for building radiation-shielding habitats, as well as developing advanced spacesuits that can provide adequate protection during surface activities. To sum it up, the discovery of organic molecules and the successful operation of MOXIE on Mars have brought us one step closer to understanding the red planet's potential for hosting life and supporting human exploration. As NASA and SpaceX continue their ambitious plans for human missions to the Moon and Mars, new scientific breakthroughs and technological innovations will pave the way for a sustainable human presence on these celestial bodies. The journey to Mars has only just begun, and the coming decades promise exciting discoveries and achievements in our quest to explore and settle the red planet. Thank you for watching. Your activity is very important to us. Subscribe to the channel and let us know in the comments if you believe that life on Mars will be ever found, and if you'd like to be among the first colonizers of the red planet. We're excited to know what you think. As Thomas Berger once said, the art and science of asking questions is the source of all knowledge.